Okay. It's a super great honor and pleasure to be back. I was here, what, like 4 months ago or something, over at the other location, and had a group like yours to talk about what we teach at Singularity University. So what I want to do is, in the next about 90-ish minutes, walk you through effectively what we do in our executive program, which is a week-long program currently running. So we've gotten currently about 100 executives from all around the world at our campus. Each of them paid $14,000 and spends a week with us. So we're doing this for free in about 90 minutes. So brace yourself. Calling this a field guide to exponential thinking, you see in a minute what this is all about. But the typical questions like people have when they come to us is kind of like, what's next? Like, what's happening in technology? How do I make sense of this change? And then for larger corporations, larger companies, how do I disrupt and not get disrupted by kids like yourself, right? For you, the question is, like, how do I kick their asses, right? So the three things we want to talk about today, I want to talk to you about, is what is happening, and talk a little bit about this notion of exponentials and how they actually work. And a lot of that you will probably know. How do you make sense of that change? So we'll talk a bit about some frameworks to give you an idea of like how this actually works. And then why does this actually matter? This is probably the most important and most interesting part, for me at least. Just as an FYI, you get the slides afterwards. There's a link. You can just download them, so you don't need to like take pictures or whatever. So I'm very open with my slides. Super briefly about Singularity University. We're kind of like, I want to say, the grown-up version of this place here. So we do the same thing, kind of, just our audience is typically 20 years older than you are. We are a mission-driven organization, and this is important to us. So our mission is to educate, inspire, and empower leaders, so people like yourself, to apply exponential technologies to tackle humanity's grand challenges. So we'll spend most of our time today to talk about this exponential technologies thing, and then we'll talk a little bit about like what does it actually mean, how do you actually apply this to tackle some really interesting big problems. Let's keep this also interactive. So if you have any questions or anything is unclear, you want to make a comment, just like throw it out, okay? So, no, you can't just like, yeah, no. So this is basically, this is the invitation. I'm a pretty sociable guy. Like you find me everywhere and anywhere, or like on the interwebs, like there. So Twitter, Facebook, LinkedIn, Snapchat, you name it. So let's talk a little about what's happening in the world. Like what is the change we're seeing? And this is kind of like the macro level of the work you're already doing, okay? L.P. Hartley, who's a futurist, once said that the past is a foreign country. And I think it's really important to understand the past if you want to understand the future. So there's a little bit of like history here. And history here in Silicon Valley is you have most likely heard of Xerox PARC. So Xerox PARC's just like, I don't know if you had the chance to see it, but it's super close. It's a couple of miles down the road in Palo Alto. And what they did in the late 60s and 70s is really remarkable. They basically had a group of people like yourself and about the same size, typically. So the core staff of Xerox PARC was only about 25 people, and the total of Xerox PARC was about 250 people. So tiny little group in comparison. And in a very short period of time, in only 7 years, they invented roughly 50% of what is the underlying technology which makes the internet. They invented laser printing, which led to the desktop publishing revolution. They invented Ethernet, which led to the connected desktop revolution. And most notably, probably the graphical user interface, so the thing you use today on your Windows or Macintosh. And the way they did this is, one of the key instigators once framed this coin, Alan Kay. He said the best way to predict the future is to invent it. There's something interesting in this sentence, right? The interesting part in this sentence is, A, it is in your hands to create the future. You can invent the future, and it's actually on you to invent it. Secondly, if you're not doing this, and this is more importantly, if you're not creating the future you want to have, you become basically like a piece of driftwood in the river of life, right? Like you are like, this future happens to you. This is Alan Kay, 2008, showing a computer called the Dynabook. This is at the Computer History Museum in Mountain View. And the Dynabook, this is 2 years before Apple introduced the iPad. So the Dynabook is a folio computer. You see it has a little touch screen, little keyboard here. Kind of like a cruder version of the iPad. This is 2 years before Steve Jobs gets on stage and says, one more thing. Now, this is curious, right? It's interesting. It's not like revolutionary. We had tablets around the same time. It's like it was in the air. It wasn't like, oh my God, like they invented the future. You go back 30 years, in 1972, Alan Kay wrote a 30-page long paper describing this Dynabook in great detail. That is the future. So when you go back into this document, it's actually really fascinating because he describes this computer despite the fact that this computer there was no way in hell he could actually build this. Right? Computers were a room full of electronics. A lot of the components, such as the touchscreen, didn't even exist. But what Alan Kay could do is, and I'm trying to teach this today for you, is he could look at the past and extrapolate the past and make an assumption about the future. So he could look at, okay, like for the last 10 years, I've seen computers getting smaller, more capable. A lot of new technologies are coming out. If I project this into the future, I can invent this future. Now, it took him 40 years to build this. It took him 40 years for the technology to catch up with his vision. And what you'll also see is that that time frame shrinks dramatically today. Like what was 40 years is probably now 4 or 2. The other thing which is interesting is not only could he predict the technology, he could also predict the use case. So when you look through this document, the way he describes this computer, he's talking about this computer being the perfect companion for children as a learning and entertainment companion. And if you see people using iPads, I tell this again, if I have an older audience, right? I always ask them, do you've got kids? And they're like, yeah, I've got kids. And I'm like, do you've got an iPad or a tablet? And they're like, yes, I do. And I was like, who's using it? It's always the kids, right? So it's really fascinating to see how you can actually, if you put your mind to it and if you know what you're doing, you can actually predict this future. This is Alan Kay, 2012, at the demo conference. He says something really interesting. I just want to play the clip quickly. Oops, I thought I can play the clip. There we go.
On the other hand, we spent roughly 2 to 3 times the person's salary each year just on technology for that person. Because we were buying, as I'll show you, we bought our way into the future. Because Moore's law says that if you're interested in something 15 years from now, you can have that computing power now if you're willing to pay through the nose.
That's important. What is important is that the future is already here. If you wanted to know how virtual reality will look like today, Oculus Rift, HTC Vive, you could buy that future 5 years ago, 10 years ago. It was just really expensive. So there's actually a shortcut for you guys to hack the future, which is you just need to look at the shit which is really expensive today, because that stuff will get super cheap very, very quickly. William Gibson, he's a science fiction author, said that the future is already here. It's just not evenly distributed. Right? The future exists. You just need to find it. You need to look for it. So that's another, it's a shortcut. It's a hack.